Here's a quick look at the nice triangles again now that we have the notion of radians. Remember we had the 45-45 right triangle, but if we do this in radians now, a 45-degree angle is pi over 4 radians, and pi over 4 radians, the right angle would be pi over 2 radians. So still, side lengths 1, 1 and the square root of 2. I can see things here like what's the sine of an angle pi over 4? Right? If I put my calculator in radian mode and type in sine parentheses pi divided by 4 close parentheses and ask it what it is, it's going to say 0.707 because it's going to figure out that it's 1 divided by the square root of 2. I'm looking at this 45-degree angle thinking opposite over hypotenuse. Right? 1 divided by the square root of 2 is, 0.707 something. It's irrational. It'll go on forever. But what's the cosine of pi over 4? Your calculator in radian mode would calculate what the sine and cosine of pi over 4, but I can see it's the adjacent over the hypotenuse, which is 1 over the square root of 2. Right? This is the same as what we were doing with 45 degrees. What's the tangent of pi over 4? Well, it's the opposite over the hypotenuse, which is 1 over 1. Likewise, we've got the 30, 60, 90 triangle, which I'll draw here. There was a right angle. This was side lengths 1, 2, and the square root of 3. When we were doing radians, I called this 60 degrees and not 30 degrees. But now that we're doing when we did degrees, it was 60 and 30. Now that I'm doing radians, this is pi over 3, and this is pi over 6. It always takes me a little bit to remember that when I'm dividing by 6, I'm getting a smaller answer than when I'm dividing by 3. So pi over 3 is the bigger angle, and pi over 6 is the smaller angle. So what's the sine of pi over 6? Sine of pi over 6 is opposite over hypotenuse. It would be a half. I'm just doing some random ones here. What's the tangent of pi over 3? Looking at this pi over 3, opposite over adjacent side, it's radical 3 over 1. Okay. You can look at that triangle and get all 6 trig functions of those two nice angles, pi over 3, pi over 6. And then up here you can use that triangle for pi over 4. Likewise, we can talk about some big angles like what's the sine of 7 pi over 6? So the first thing I got to do in 7 pi over 6, I got to figure out where the heck that is. Well, 6 pi over 6 would get me here. So 7 pi over 6 must be a pi over 6 beyond 6 pi over 6. Right? 6 pi over 6 is the same as pi. That's the half turn. Then you need another pi over 6 for 7 pi over 6. So you're talking about being pi over 6 down into the third quadrant. Well, hey, we've got a 1, 2, square root of 3 triangle in here. I'm in the third quadrant, so I want to make both the x and the y coordinates negative. So the sine is going to be the y coordinate over the hypotenuse, minus 1 over 2. Okay. What's the cotangent of 3 pi over 4? Well, I got to figure out where 3 pi over 4 is. 3 pi over 4, well, there's 1 pi over 4, 2 pi over 4. 3 pi over 4 will be right up the middle of the second quadrant. Drop a perpendicular here. You're talking about a pi over 4 angle left over right there. So you got your 1, 1, square root of 2 triangle, and the x-coordinate is negative. So what's the cotangent of 3 pi over 4? It's the y-coordinate divided by the x-coordinate. This is your 3 pi over 4 angle out there. This is the reference angle right in here. So opposite over adjacent. No, that's the tangent. So the cotangent would be the adjacent over the opposite. It's minus 1 over 1, which is just the same as minus 1. Okay. There isn't a need to convert these angles to degrees if you can think in terms of multiples of these nice angles. Pi over 4, you know what that is. I've got 3 of them. 1, 2, 3. Pi over 6, I know what that is. I've got 7 of them. 1, 2, 3, 4, 5, 6, 7. Right? That you get that angle by looking at a fraction of pi. The pi over 6 is the angle I really recognize, and then I say, oh, count out 7 of those. Pi over 4 is the one I recognize. Count out 3 of those. And you see what those angles are. Okay.